Hey Cloud Architects! Azure offers a buffet of compute services, but picking the right one isn't just about features. It's about scalability, cost efficiency, and operational fit. Choosing the wrong pattern could mean higher costs, performance bottlenecks, or a DevOps nightmare. Are you building a SaaS platform, a workflow automation engine, or a microservices-driven API? Each workload demands a different approach, and knowing when to use App Service, Container Apps, Logic Apps, or AKS can make or break your cloud strategy. In today's deep dive, we're breaking down the 4 major Azure compute patterns, so you can confidently choose the right tool for the job, avoid common pitfalls, and future-proof your architecture. Let's get started. Compute pattern. Comparison matrix. Picking the right Azure compute service. Not all compute services are created equal. Choosing the right one depends on development complexity, operational overhead, scalability, and cost predictability. Here's a comparison to help you match the right Azure compute service to your workload. Number 1, Azure App Service, simple and scalable web apps. Best for traditional web applications like ASP.NET, Java, Node.js, and Python, customer-facing portals, API backends, and content management systems. Real-world example, a scalable e-commerce website. An e-commerce website experiences variable traffic patterns, with occasional peaks during sales events or holiday seasons. To handle this fluctuating demand, the application requires a scalable backend, strong security measures, and seamless content delivery. Key characteristics: traffic pattern, highly variable with sudden spikes during promotions. Data needs, relies on a SQL database for transactions and blob storage for product images and media files. Security measures, enforced with SSL encryption and a web application firewall, WAF, to protect against threats. Scaling strategy, uses auto-scaling based on CPU usage to ensure smooth performance during peak demand. Why choose Azure App Service? Easy deployment pipelines support CI/CD integration, enabling seamless application updates. Built-in auto-scaling adjusts resources dynamically based on traffic demand. Managed SSL and custom domains simplifies security setup with built-in SSL management. Azure CDN integration speeds up content delivery, ensuring a fast and responsive user experience for customers worldwide. Takeaway: for an e-commerce site that requires rapid scaling, built-in security, and minimal infrastructure management, Azure App Service is an ideal solution, balancing ease of use, performance, and reliability. Azure Container Apps, or ACA, represents the future of cloud-native applications. It's best suited for microservices architectures, event-driven applications, background processing workloads, and DPR-powered APIs. Let's look at a real-world example: an event-driven order processing system. An order processing system needs to handle high transaction volumes, real-time event processing, and seamless service communication to ensure fast and reliable order fulfillment. To achieve this, a microservices architecture is implemented, where each component, such as order validation, payment processing, and shipment tracking, operates independently while being event-driven. Key characteristics include: the architecture is designed using a microservices model, where independent services interact efficiently without creating bottlenecks. The scaling trigger is event-based, meaning services only consume resources when needed, making it highly efficient. Communication uses DPR, or Distributed Application Runtime, pub/sub messaging, allowing services to communicate asynchronously without tight coupling. Dependencies incorporate Redis for caching, ensuring fast response times, and MongoDB for scalable, flexible data storage. So why choose Azure Container Apps? Native DPR support simplifies microservice communication with built-in pub/sub messaging, service discovery, and state management. Event-driven scaling automatically adjusts resources based on workload fluctuations, ensuring efficient processing without over-provisioning. Modern networking features provide secure service-to-service communication, built-in load balancing, and distributed tracing for improved observability. It's also cost-effective for microservices, offering serverless scalability, reducing operational overhead, and eliminating the need for a fully managed Kubernetes cluster. The takeaway: Azure Container Apps is an ideal solution for event-driven microservices, delivering scalability, flexibility, and cost efficiency while simplifying service communication and management. Azure Logic Apps is the integration powerhouse. It's best for business process automation, system integration with API-first workflows, data pipelines and scheduled jobs, and orchestrating external SaaS applications. Consider a real-world example: automated invoice processing. An invoice processing system must efficiently handle multi-step workflows, integrate with various services, and ensure compliance with business rules. Given the complex nature of financial approvals and documentation, an automated event-driven approach significantly enhances efficiency and accuracy. Key characteristics include: the workflow follows a multi-step process, including invoice validation, approval routing, and payment processing. Integrations connect seamlessly with email for invoice submissions, SharePoint for document storage, and SQL for financial records and reporting. The system requires dynamic business rule enforcement, such as multi-level approvals, conditional routing, and exception handling. Monitoring provides real-time business metrics to track invoice status, processing times, and bottlenecks. So why choose Azure Logic Apps? The visual workflow designer enables low/no-code automation, making it easy for non-developers to configure workflows. Built-in connectors seamlessly integrate with Microsoft 365, SAP, Dynamics, and third-party applications, reducing the need for custom code. It's ideal for business process automation, ensuring compliance with financial regulations. Serverless scaling automatically adjusts based on workload, ensuring invoices are processed efficiently without infrastructure overhead. The takeaway? Azure Logic Apps is the perfect solution for invoice processing workflows, providing seamless integration, automation, and scalability, all without requiring complex development effort. Azure Kubernetes Service, or AKS, is the powerhouse for complex applications. It's best for large-scale microservices, full container orchestration, multi-region deployments, and highly available enterprise-scale applications. Let's dive into a real-world example: a global trading platform. A global trading platform requires a highly scalable multi-region infrastructure to support real-time transactions, data processing, and market analysis across multiple time zones. Given the need for low-latency, high-availability microservices, a containerized approach ensures resilience, performance, and seamless scaling. Key characteristics include: the scale operates on a global level, spanning multiple regions for redundancy and optimized performance. The services comprise over 100 microservices, each handling specific aspects of trading, risk management, compliance, and reporting. The requirements demand high availability to maintain continuous uptime and low-latency processing for real-time financial transactions. The team is managed by a dedicated DevOps team, ensuring infrastructure automation, security compliance, and performance tuning. So, why choose Azure Kubernetes Service? It offers complete container orchestration, managing large-scale microservices efficiently, handling deployment, scaling, and security. Advanced networking supports service mesh integrations, multi-region traffic routing, and private networking to minimize latency. Custom scheduling provides fine-grained control over workload distribution, optimizing resource usage and cost efficiency. Infrastructure as code, or IAC, enables fully automated deployments with Terraform, Helm, and GitOps, ensuring consistent and repeatable infrastructure management. The takeaway? Azure Kubernetes Service is the ideal choice for large-scale, high-performance containerized applications like a global trading platform, offering resiliency, advanced networking, and automation at enterprise scale. Why do approved design patterns matter? Well, when it comes to cloud architecture, reinventing the wheel isn't just inefficient, it's costly, time-consuming, and honestly, prone to errors. Instead of starting from scratch, developers can leverage approved design patterns that provide proven, repeatable solutions for common workloads. Using pre-approved patterns, for example, streamlines development, testing, and deployment. This allows teams to launch applications faster without endless reconfiguration. Patterns also incorporate built-in best practices like security, scalability, and cost optimizations, which reduce the risk of misconfigurations. And let's not forget about consistency. Standardized architectures simplify collaboration, governance, and maintenance across multiple projects. So here's an example. Instead of manually architecting an e-commerce backend, developers can follow a validated app service plus SQL plus CDN pattern, cutting deployment time from weeks to days. The bottom line? When developers use pre-approved Azure compute patterns, they build faster, reduce technical debt, and ensure scalability right from the start. Deploying applications in Azure is not just about picking the right compute service. It's about understanding the surrounding cloud services that enable scalability, security, and efficiency. To deploy applications effectively, developers and DevOps engineers should complete Azure training and certifications to gain cloud proficiency. Top training recommendations. 1. Azure Fundamentals, AZ900. Ideal for beginners, covering Azure core services, security, and cost management. 2. Developing solutions for Microsoft Azure, AZ204. A must for developers, focusing on compute, storage, security, and monitoring best practices. 3. Azure Administrator, AZ104. Great for DevOps teams, covering networking, identity management, and automation. 4. Azure Kubernetes Service, AKS. Deep Dive. Perfect for teams moving to microservices, focusing on container orchestration and DevOps. 5. AI 900 and DP 100. AI and data engineering. For developers working on AI-powered and data-driven applications. Pro tip: teams transitioning to AKS should start with Azure Container Apps, ACA, before diving into full Kubernetes orchestration. Why cloud training is essential. Boost deployment confidence. Knowing how Azure services interact ensures smoother app rollouts, prevents costly mistakes. Misconfigured networks or storage policies can lead to unexpected cloud bills. Improve security and compliance. Proper RBAC and encryption practices reduce vulnerabilities. Enables future-proofing upskilling, helps teams adapt to evolving cloud technologies like AI-driven automation and serverless architectures. Choosing the right Azure compute service can make or break your cloud architecture. Here's a quick recap to help you pick the best option based on your application needs, scalability goals, and DevOps expertise. Azure App Service. Quick deployment with minimal setup. Managed security, SSL, custom domains, WAF. Suitable for teams with limited DevOps experience. Predictable pricing model, requires full OS-level access. Complex networking or security rules needed. Large-scale microservices architecture required. Azure Container Apps, building a cloud-native, event-driven system. Need Kubernetes-like features without cluster management. DAPR integration required for service-to-service communication. Auto-scaling needed based on events. Kafka, Azure Queue Storage. Monolithic applications or legacy dependencies. Requires full control over the container runtime. Large-scale Kubernetes cluster with complex networking needed. Azure Logic Apps, low/no-code integration solution required. Need to orchestrate workflows across multiple services. Team lacks deep software engineering experience. Serverless scalability is a priority. Complex business logic requiring custom coding. High-performance real-time processing needed. Workflow involves large data sets with heavy transformations. Azure Kubernetes Service, AKS. Managing a large-scale application with complex dependencies. Full control over networking and security is required. Team has strong Kubernetes expertise. Advanced CI/CD workflows needed. Small projects that don't require Kubernetes orchestration. Team lacks Kubernetes expertise. AKS has a learning curve. Need for a simpler, cost-effective solution. AKS can be expensive to manage. Pro tip: teams with no Kubernetes expertise should start with Azure Container Apps before moving to AKS. Mini-tech glossary: compute scaling, automatically adjusting compute resources based on workload demand. Serverless running code without managing underlying infrastructure. Event-driven architecture: apps that react to real-time events instead of waiting for scheduled tasks. Microservices: a cloud-native approach where apps are split into loosely coupled services. DAPR, distributed application runtime, a framework for microservice to microservice communication. Choosing the right Azure compute service is about more than just features. It's about finding the perfect balance between performance, scalability, operational efficiency, and team expertise. A well-architected solution ensures long-term maintainability, security, and cost-effectiveness, helping you avoid unnecessary complexity. Each compute option serves a distinct purpose. Need simplicity? App Service offers a fully managed solution for web apps and APIs with minimal DevOps overhead. Building cloud-native applications? Container apps give you serverless container orchestration without needing a full Kubernetes cluster. Orchestrating integrations, Logic Apps enable low-code automation across multiple services with built-in connectors. Managing large-scale microservices, AKS delivers enterprise-grade container orchestration, networking, and DevOps control. Making the right choice now will save you from unnecessary migrations and technical debt later. Misaligned compute decisions can lead to higher costs, scaling limitations, and increased maintenance overhead. Investing time in architecting the right solution upfront means fewer headaches and greater agility as your application evolves. Your move. Is your current architecture optimized for performance, scalability, and cost? Or is it time to rethink your strategy, align with best practices, and future-proof your cloud deployments?